Hey Algebra 1, and thanks for tuning in. Today we're going to be looking at your Chapter 8 test review, so let's go ahead and get started. The first thing we're going to do is find the vertex and the axis of symmetry. Just remember your vertex in vertex form would be h comma k. So your vertex is going to be -5, comma, -4, and your axis of symmetry would be x is equal to -5. Number 2 is not quite in vertex form. It's actually in what we have as your intercept form. So what we're going to do is go ahead and find the axis of symmetry. Remember, we can do that by finding the average of P and Q. So that means I'm going to take +4 plus -2. So remember, it'd be P minus Q, P minus X minus P, X minus Q, and divide that by 2. I'm going to get 2 over 2, which is equal to 1. So then I go back and plug in x to find my y. I already know that my axis of symmetry is going to be equal to 1 though, since x is equal to 1. So when I plug that back in, I'm going to have y is equal to -3 parentheses 1 minus 4 parentheses 1 plus 2. I'm going to go ahead and solve these. 1 minus 4 is -3, 1 plus 2 is +3. So y will be equal to a positive 27. So my vertex is 1, 27. For number 3, this one is in standard form. So again, I can choose maybe to use -b over 2a to find my x value and then plug in for my y. -b is 16, and 2 times a, that'd be 2 times 4. That's going to be -16 over 8. Which is equal to -2. So x is equal to -2. And again, I'm going to plug in my x value and solve for y. So I would have 4 parentheses -2 squared plus 16 times -2 plus 7. That's going to give me basically 4 times 4 minus 32 plus 7. So it'd be 16 minus 32, just working left to right now with PEMDAS, and then I'd get -16 plus 7, which is equal to -9. So my vertex is -2, -9. For number 4, this one is in vertex form. Notice you have your h but no k. So h is 3, k is 0, which means axis of symmetry is equal to 3. This one you can solve for your zeros or do your your average of your p and your q. So p is -3, q is -2, and we're going to divide by 2. So this is how we can find our x value. That's going to give me -5/2 as my x, which means that is my axis of symmetry. It's a little bit trickier here now as we solve for y. All we're going to do though is just plug that in, and I'm going to actually change -5.5 to -2.5. So -2.5 plus 3 parentheses -2.5 plus 2. I'm going to get 4 times +1/2 times -1/2. That's going to give me 4 times -1/4, which is equal to -1. So y is equal to -1. So my vertex would be -5/2, -1. Number 6, this one can be written, this one's written in standard form, so we're going to use x is equal to -b over 2a. So -b is -6, so that's, you can technically change that to a +6 over 2 times 1/2. That's going to give us 6 over 1, which is just equal to 6. So that would be my axis of symmetry. Now let's just go back and plug that in. So I have 1/2 times 6 squared minus 6 times 6 plus 10. That's going to give us 1/2 times 36 minus 36 plus 10, or 18 minus 36, plus 10. That would be -18 plus 10, which is equal to -8 as my y. So I'll have 6, -8 for my vertex. The next one, we're writing a graph of a function, the parent function f of x squared. F of x is equal to x squared. It's translated 4 units to the left and then 1 unit down. I know 4 units to the left is going to be that x plus 4, because h would be negative 4 squared, and then 1 unit down would be minus 1. I don't have anything where I'm stretching or shrinking, so I'm actually going to name this g of x since it's a transformation. My function would be this, x plus 4 squared minus 1. For this one, we're going to describe it. The graph is going to open downward because it's negative, and it's also going to be twice as narrow as the parent graph. Another way you can say this is you can also say that it's stretched 2 times as narrow as the parent graph. Let's go ahead and go to the next page where we have writing in vertex form. Your vertex is negative 4, negative 2, and it's going to pass through the point negative 7, 7. So the first thing we want to do is write our vertex form. Y is equal to parentheses x minus h squared plus k, and then go ahead and fill in everything except for a. So I'm going to have 7 is equal to a parentheses negative 7 plus 4, because minus negative 4 would be positive 4. And then plus k would be plus negative 2, or just minus 2. And then we're just going to go ahead and solve here. So we'll have a is equal, or a times negative 3 squared minus 2. That would be 9a minus 2 is equal to 7. I'm going to add 2 to both sides. So 9 is equal to 9a, which means a is equal to 1, which for us, that's going to make our function look like this. X plus 4 squared minus 2. Since a is equal to 1, we don't need to include it in the front, but if you did, that would be fine. This one we're going to write in standard form. So remember, standard form is ax squared plus bx plus c. And to see what that would look like passing through all these points, since you're given 3 points, I would start off using your intercept form, which is a parentheses x minus p times x minus q, and then plug in your values. So my 2 x-intercepts, those are going to go in where p and q are. So minus negative 3 is positive 3, and minus 1 is minus 1. And then your x values are negative 1. So again, we don't know what your a is. And then y is 8. Okay, so we're going to go ahead and solve. So 8 is equal to a times 2 times negative 2. That's negative 4a is equal to 8. So a is equal to negative 2. So we can now go ahead and plug that in to our original equation back up here. Y is equal to negative 2 parentheses x plus 3 times x minus 1. And the nice thing here is that we can just FOIL the intercept form to make it into standard. So that'd be negative 2 parentheses x squared plus 2x minus 3. And then if we distribute the negative 2 to everything, we're going to get negative 2x squared minus 4x plus 6. So that would be our function, f of x right here. Okay. The next piece is we're just going to find our zeros. What I did first is I factored out a negative 1 because I don't want a is equal to negative 1. So when I factor out a negative 1, I'm going to get x squared minus 16, and then I notice that's the difference of 2 squares. X plus 4 times x minus 4. Still can keep the negative 1 on the outside, but basically x would be equal to negative 4 and x would be equal to positive 4. We can't include the negative 1 because negative 1 does not equal 0. For number 12, we can factor out a 3x, and I'm going to go and set this equal to 0 as well. So 3x parentheses x minus 2, and then set everything equal to 0. 3x is equal to 0, and x minus 2 is equal to 0. For this first one, x is equal to 0, and the second, x is equal to a positive 2. 13, it might be beneficial to factor out a negative 2 first. So I'm going to have x squared plus 5x minus 6, and then I'm going to factor the factors of negative 6 that add to a positive 5 would be a positive 6, so x plus 6, and a negative 1. And then I'm just going to go solve x is equal to negative 6 and x is equal to a positive 1. Again, can't use the negative 2 because it's not equivalent to 0. For this one, it might be beneficial to just go ahead and, since you have everything FOILed, go ahead and set these individual binomials equal to 0. So 3x minus 1 is equal to 0, 2x plus 7 equals 0, and then solve. So I get 3x is equal to 1, so that means x is equal to a third. And then over here, we would have, 2x is equal to negative 7, so x is equal to negative 7/2, so you can say negative 3.5. Okay? For number 15, it says the function y is equal to negative 16x squared plus 144 represents the height y in feet of a pencil x seconds after falling out the window of a school building. After how many seconds does the pencil hit the ground? So first we'd maybe want to write our formula. And we're essentially just solving for zeros here. So I'm going to factor out negative 16 first, since that's my GCF. Minus 9, and then this is the difference of two squares, so x plus 3 and x minus 3, and then when I solve, I'm going to get x is equal to negative 3 and x is equal to positive 3, but I can't have negative seconds. This is not possible. So I would choose x is equal to 3 or say 3 seconds. Okay. Over on the back, these are just pretty simple. Your domain is all real numbers, and same thing for number 17. For number 16, your range has to be less than or equal to 4, so y is less than or equal to 4, and your y-intercept looks like it's intercepting right here at negative 2. The range for number 17 has to be greater than or equal to negative 2, and your y-intercept also looks like it is at negative 2 for number 17. For 18 and 19, we're finding our minimum and maximum values. Remember, we're just looking at a specific part here. And just a reminder, if you wanted one, your minimum value is when a is greater than 0, and your maximum value is when a is less than 0. So for number 18, so in this case, you're going to have a minimum for number 18, because your a is greater than 0. Remember, to find the value, you have to find your y value of the minimum or the maximum, because that's going to show your peak or your valley. So what we need to do is go ahead and find x first, and then we can find y. So how to find x is I just use negative b over 2a since we're in standard form. So that would be positive 20 over 2 times 5, which is 20 over 10, or 2. So x is equal to 2, so then I go back and plug it in to find my y. So 5 times 2 squared minus 20 times 2 plus 3. That's going to be 5 times 4, which is 20, minus 40 plus 3. 20 minus 40 is negative 20, plus 3 is negative 17. So if y is equal to negative 17, my value is negative 17. For number 19, a is less than 0, so that one is going to be my maximum. And then let's go ahead and find the value the same way we tried 18. So negative b over 2a. Negative b would be negative 12 over 2 times negative 3. That is negative 12 over negative 6, which is equal to a positive 2. Again. Then we're going to go back and plug that in. So negative 3 times 2 squared plus 12 times 2 minus 7. Negative 3 times 2 squared, that's going to be negative 3 times 4, negative 12. Plus 24 minus 7, that's negative 12, plus 24 is negative 12, and then minus 7, or positive 12 minus 7, which should give you 5. So y is equal to 5, which means your value is equal to 5. Okay. For number 20, this one should be a quadratic, because you have the difference of minus 2, plus 2, plus 6, and then plus 10, but each of these have the same distance, plus 4, plus 4, plus 4. So what I did here is I found my 0, 3 first. That's going to maybe tell me my vertex. But more importantly, what I can do is use my vertex form. So y is equal to a parentheses x minus h squared plus k. And then what I'm going to do is plug in my vertex, and then my goes through any of these points. So my h comma k, I'm going to do a 0, 3. That's my vertex. And then I'm going to pick a point. I'm going to pick 1, 5. So I'm going to pick this point. So x is 1, just so I can deal with more positive numbers than anything and still low enough numbers. And I'll say my y is 5. So I just chose, again, this point right here. And then go ahead and solve. 1 minus 0 is 1 squared. 1 squared plus 3, or times 3. So I have 1a plus 3 is equal to 5. So a is equal to 2, because I subtracted 3 from both sides. So then I would just plug that in and write my equation. Y is equal to 2x squared. I don't have an h because h is 0, and then so I just add my k at the end to be plus 3. So for the next one, linear, this one is going to be linear because they have the same difference. If you check out your y's, you're adding 2 each time. Remember, with linear, you just find out where you start. So here's your y-intercept. So that's gonna be your b. Remember, we have y is equal to mx plus b. And then your m is your slope. So just figuring out how much it goes up. Since we're going up by 2, that means we're going up by 2 total. So that'd be a positive 2x. So y is equal to 2x plus 12 for your function. And then in this one is obviously going to be exponential because you're multiplying by a half, or dividing by 2, same thing. So my function is exponential, and then my actual equation, or actual function, of y is equal to 1/2 to the x power. Since you're multiplying everything by 1/2, that's what you need to show as your function there. The last page, all we're doing is graphing. You're going to plot and label 5 ordered pairs. So again, what might help first is do your vertex. So your vertex is 2, -3. So over 2, down 3. 1, 2, 3. And then I just did when x is equal to 1 and when x is equal to 0, just because they were different distances, and I was able to plot and do these kind of quickly. So here's where I plugged in my 1. So that was going to give me y is equal to -1 squared minus 3, or -1 minus 3, which is equal to -4. So I have 1, -4. And then when x is equal to 0, this is what that would look like being plugged in. And then going and solving, -2 squared minus 3, that's -4 minus 3, or -7. So my ordered pair there would be 0, -7, which is at that very end. And then you're just going to draw your other 2 symmetrical points and curve it. Okay. 24, same type of deal here. You could go ahead and maybe solve for your zeros first. Your zeros are x is equal to 6 and x is equal to 2. So on the x-axis, you would just find those. Here's 2, 3, 4, 5, 6. So what we need to do is find the vertex. Remember, we can find the vertex by finding the average of p and q. So p plus q divided by 2. That would be 6 plus 2 divided by 2, or 8 divided by 2, which is equal to 4. That's your x value. To find your y value, you just go back and plug it in. So negative parentheses 4 minus 6 parentheses 4 minus 2. That's going to be negative parentheses -2 times 2, or negative 4, which is equal to just a positive 4. So x is equal to 4, y is equal to 4. That means my vertex is 4, 4. 1, 2, 3, 4, 1, 2, 3, 4. And then to find other points, I maybe could just choose a different distance. So I'm going to choose 1. So if x is equal to 0 or x is equal to 1, I could just plug that in. When x is equal to 1, y is going to be equal to negative 5. And just do that for the sake of time here. Which means my other point would be over here. Okay, so there's your 5 points, vertex and your other 2 ordered pairs. And then the last one, again, you can just find your vertex first, since this is technically in either standard or vertex form. Your vertex is 0, negative 4. There's no h, but there's a negative k. And then we can just use maybe x is equal to 1 and x is equal to 2. Can't use 0 here. So when x is equal to 1, that's 2 times 1 squared minus 4, or 2 minus 4, which is equal to negative 2. So 1 comma negative 2. And then when x is 2, just plug that 2 in. So that's 2 times 4 minus 4, or 8 minus 4, which is equal to 4. So that would be 2 comma 4 as another one. 1, 2, 2, 3, 4. Oops. So then you would just, again, make your symmetrical points and curve it. Okay? Thanks so much for being patient as we went through the entire Chapter 8 test review. Again, good luck on your test, and we'll catch you next time.